Hello, this is Dr. Hassan Abdullah with the course Complexity and Analysis of Algorithms. The topic which we are covering is dynamic programming, and the subtopic is comparing dynamic programming with recursion. So, dynamic programming is the seventh topic, so the lecture is 7C. It means that we already have 7A and B. This is the last subtopic within the topic of dynamic programming. So, this video lecture is built using the platform and the supplemental material available at easymcq.com/goget. So, this easymcq.com is a learning management system, and more precisely, it's a personalized learning management system. Personalized in the sense that you can set the level of your learning and the type of learning you would like to pursue, and personalized that you can set the interface as per your requirement, as per your need, font, color, shape, and so on. And how you do this for the personalized learning, video 1 shows you, and how you set the interface, video 4 shows you, and how you personalize your testing online and evaluation, that is shown on video number 5. So these 6 videos and the videos of this course and other courses also, they are available on my YouTube channel. So to find these videos and other videos, you just type my name, Dr. Asan Abdullah, in YouTube, and it will take you to my YouTube channel where all the videos are available. So let's move on to the course outline. So we see that this course outline basically consists of 11 topics, and right now we are towards the end of the topic number 7, which is dynamic programming. And I also have a topic of advanced algorithms, which covers randomized algorithms, approximate algorithms, and genetic algorithms. So now we move on to the supplemental website. So we are at the supplemental website, and the first 10 questions have been covered in videos 7A and 7B. So now we will cover these last 4 questions and their answers in the lecture 7C. So what are the limitations of dynamic programming? So dynamic programming, these are the bullets. So these become very helpful when you are revising the course towards the mid exam or the final exam or towards some interview also. So the limitation of dynamic programming is high memory usage, because we need to place the stack values, the data, and the reference information on a stack, and that requires space. So high memory usage as compared to plain recursion. Complexity in problem formulation. You need to formulate the problem in such a way that you have the optimal substructure and you have overlapping sub problems, and you have to define it in such a way that dynamic programming can be used efficiently, and that requires a lot of effort. So when that effort is done, all right, so you have the overhead for it. So this effort is overhead if the problem size is small. So it is like it's overkill. So for small problems, we are better off using recursion. And limited applicability to certain problems. For example, dynamic programming typically is for optimization. So it would be not carry a lot of meaning if dynamic programming is used for sorting. Requires problem decomposition. The problem should be able to be broken into smaller subproblems, which should be overlapping, so that there is no redundancy. Difficulty in handling constraints. So when there are constraints, so how you develop or include those constraints within the framework of dynamic programming. Solution reconstruction challenges. So once the sub solutions have been developed by using the prior solutions, then the question is how you combine those sub solutions such that you have the overall solution. That's the challenge, and it's not always the fastest for simple problems. So let's look at it in more detail. Okay, so let me first clear the screen also. All right. So high memory usage we have discussed. Complexity in problem formulation. What is the complexity? Complexity is identifying the overlapping subproblems, creating the recurrence relations. Why difficult? Because it requires insight and experience, insight of the problem and experience of doing these things. So therefore, there's an issue with dynamic programming. It is less intuitive for beginners, kind of challenging, kind of having a steep learning curve. For smaller problems, the overhead of storing the subproblem solutions, okay, may outweigh the benefits. So there's more overhead than the benefit itself. And for certain problems with overlapping subproblems and optimal substructure, for this it is suitable. But if this is lacking, then cannot be efficiently solved using dynamic programming. Requires problem decomposition, so you need to be able to break into smaller subproblems. And the problems that are difficult to break down, okay, or do not exhibit optimal substructure, then of course dynamic programming is not a good choice. It is impractical. And of course there could be non-linear constraints or dynamic input sizes, and they are difficult to model. Why? Because it requires additional handling. or modifications of the standard approach, and which can introduce a lot of complexities and issues also. So, solution reconstruction challenges. It may not be straightforward, okay, after filling the dynamic programming table. Why? Because it requires additional backtracking or storing the extra information, which what complicates the implementation. And when things get complicated, then they are difficult to code and difficult to maintain also, and so on. And it is not always the fastest approach. So that becomes an overhead. So what are the advantages of dynamic programming over simple recursion? Let's take a look at this. Okay, so what it does is that dynamic programming avoids redundant calculations. Say, for example, if we are using Fibonacci series for Fibonacci numbers using a recursion, that can be non-polynomial. Okay, why? Because of repetitive recalculation of the lower values of Fibonacci numbers. So, but when you are using dynamic programming, you avoid those redundant calculations. So it has a better time complexity, which is they are both together. Memory efficiency. Let's take a look at memory efficiency. In certain cases, dynamic programming is more memory efficient because it stores intermediate results in a table. While for recursion, they basically the stack is full of repetitive work also. So, for example, this Fibonacci sequence, right? The systems call back for function calls lead to stack overflow. So, using more memory than the more that was assigned. But dynamic programming uses tables to store intermediate results and avoids deep recursion. Okay, because deep recursion places a lot of stuff on the stack. Then, of course, optimized for overlapping subproblems. Dynamic programming is optimized for such class of problems. Okay. So in a naive recursive approach, subproblems may be recomputed again and again and again, right? While dynamic programming solves each subproblem only once. So for example, in dynamic programming, okay, the Fibonacci 3 and Fibonacci 4, they are they are used only they are only calculated once, but using a recursion they're multiple times. So here is some code for your understanding. So dynamic programming approach, a bottom-up approach was used. So you can see that it is. So what is the difference between recursion and dynamic programming? So they differ in terms of definition. The approach is very different. Efficiency in terms of time and space, the structure of the problem itself, and the use of memory. So let's details. Recursion using function calls. Okay, solve the problem by breaking it down to smaller subproblems. Okay, and so which is there in dynamic programming also. But the difference, there's one difference here. The difference is that in dynamic programming, the storing of the solutions, the subproblems take place. And using those solutions to the subproblems actually builds the final solution. And recursion basically computes the Fibonacci sequence recursively, like this. But dynamic programming, the Fibonacci sequence is stored by storing the intermediate results in an array or table, and then they are repeatedly called. So recursion follows a top-down approach with the problems divided into smaller subproblems, while in dynamic programming using the bottom-up approach or top-down approach, but it focuses on solving the subproblems once and storing those solutions to be used repetitively whenever they are required. Okay. All right. So efficiency is paramount. So recursion can be inefficient due to overlapping subproblem. Why? Because the same problem is computed multiple times, many times. Dynamic programming improves efficiency by storing the results of solved subproblems, eliminating repeated calculation. So for Fibonacci series, Fibonacci 5 might be recalculated again and again, but in dynamic programming only once, used repetitively. So in recursions, the problem structure is suitable for problems that have a natural recursive structure. But for dynamic programming, best for problems that have overlapping subproblems and optimal substructure property. Then you can capitalize on dynamic programming. So, okay, now let's look at more some stuff. So, for example, in dynamic programming, best for overlapping subproblems like tree traversal in the case of recursion and 0 1 knapsack for the knapsack problem. And memory usage, recursion uses memory on the function call stack and can lead to stack overflow. when more memory is required than the memory made available. But in dynamic programming, extra memory to store the results of subproblems, which are stored in a table or an array. So that allows efficient reuse of the solutions but may require more space compared to the simple recursion. But that more space depends upon the level of recursive calls also, how deep the recursive calls are. Okay, so that's about it for this comparison. And of course, we can see on the screen that recursion for Fibonacci numbers can consume a lot of memory with deep recursion. That I've already said and stated. But a reduction in recursive depth and the amount of stack memory needed for dynamic programming. So we end this comparison and the topic. Give use case and example showing the difference between dynamic programming and recursion. So let's look at the use cases for recursion and let's look at the use cases for dynamic programming, and these are the two examples which we will look at. The use case for recursion, when the problem can be broken into sub problems, okay, that are structurally similar. Okay. So in dynamic programming, ideal for optimization problems that involve overlapping subproblems and optimal substructure. So the nature of the problems for which recursion works and the nature of the problems for which dynamic programming works, they are kind of different. So a classic example of dynamic programming is the longest common subsequence, and in which dynamic programming has been utilized for a while. And there's a tool by the name of Basic Local Alignment Search Tool BLAST, which is used in the domain of bioinformatics for decades. A very successful application of dynamic programming. And of course, we can have the Fibonacci sequence. We directly apply the recurrence, okay? And the problem is that that results into repeated recalculations, and the time complexity is non-polynomial. But using dynamic programming, this reduces the time complexity to order n, so tremendous saving. There's no comparison between these two. And we have the 0 1 knapsack problem, again using the recursive approach that can result into an exhaustive, okay, search, and of course that leads to a non-polynomial time complexity. But in dynamic programming, we have a table that represents the maximum value achievable. Okay, so this reduces the time complexity. So this is a big benefit. So with this, we finish with this subtopic of comparing dynamic programming with recursion. Thank you very much.